Hello friends, how are you? Must be fine. I am Dr. Satish Chauhan, Associate Professor of Chemistry from RNC Arts, JDB Commerce and NSC Science College, Nasik Road. I welcome you in video lecture number 8 based on molecular orbital theory. In this video, we will learn molecular orbital energy level diagrams for formation of F2 and Na2 molecule. Let us consider the molecular orbital energy level diagram for F2 molecule. This molecule is formed by the combination of two fluorine atoms. Each fluorine atom has the electronic configuration 1s2, 2s2, 2p5. The 1s orbital is lower energy orbital, so it does not take part in chemical bonding. Thus 1s orbital remains as non-bonding orbital. Only 2s and 6 2p orbitals of two fluorine atoms, that is total 8 orbitals, from form total 8 molecular orbitals. Here 2s and 2p orbitals of fluorine atom are close in energy, so they interact with each other. The remaining 10 electrons of fluorine molecular orbital following above principle and Hund's rule of maximum multiplicity. The first two electrons enter into the sigma 2s orbital, bonding orbital, and the next two go to the sigma star 2s anti-bonding molecular orbital. Two electrons occupy the sigma 2px and four electrons go to pi 2py and pi 2pz orbitals, and remaining four electrons go to the pi star 2py and pi star 2pz orbit. Let us consider the molecular orbital energy level diagram for F2 molecule. This is an energy axis. These are the 2s and 2p orbitals of first fluorine atom. These are the 2s and 2p orbitals of the second fluorine atom. The combination of 2s orbital of first fluorine and second fluorine gives two orbitals, molecular orbitals, that is sigma 2s and sigma star 2s. Similarly, 2px orbital of combine together and form sigma 2px and sigma star 2px bonding and anti-bonding molecular orbitals. Similarly, 2py and 2pz of both fluorine atoms combine to form pi 2py and pi 2pz molecular bonding molecular orbitals, and pi star 2py and pi star 2pz anti-bonding molecular orbitals. Both fluorine contains 2 electrons in its 2s orbital and 5 electrons in the 2p orbital. Two s orbital is filled with the two electrons. To star orbital, 2 sigma star 2s orbital is filled with the 2s orbital. Sigma 2px orbital is filled with the 2 electrons. Pi 2py and pi 2pz are filled with the 2 electrons. Pi star 2py is filled with the 2 electrons, and pi star 2pz also filled with the 2 electrons. Thus, in bonding molecular orbital of fluorine atom, there are 8 electrons, and in antibonding molecular orbitals of the fluorine atom contains 6 electrons. Let us calculate the bond energy and bond order for the fluorine molecule. Before that, the molecular orbital electron configuration of fluorine atom, the fluorine molecule, can be written as kk sigma 2s2, sigma star 2s2, sigma 2px2, pi 2py2, pi 2pz2, pi star 2py2, and pi star 2pz2. This is the electronic configuration for Fe2 molecule. F2 molecule. Energy you hold is equal to 8 into minus b plus 6 into plus b, that is equal to 2b. The bond order of this molecule can be given by the formula 1 half into number of electrons in BMO minus number of electrons in ABMO. Therefore, that is equal to 1 half into brackets 8 minus 6, that is equal to 1. So there is single bond in F2 molecule. It contains 1 sigma bond. It has bond length of 1.44 angstrom and bond energy of 38 kilocalories per mole. The molecule is stable. Let us consider the another molecule, molecular orbital energy level diagram for Ne2 molecule. This molecule is formed by the combination of two neon atoms. Each neon atom has electronic configuration 1s2, 2s2, 2p6. The 1s orbital is lower energy orbital, so does not take part in bonding. Thus, the 1s orbital remains as non-bonding orbital. Only 2s and 2p, 6 2p orbitals of the neon atoms take part in the bonding. That is, total 8 orbitals from form total 8 molecular orbitals. Here 2s and 2p orbitals of the neon atom are close in energy. The remaining 16 electrons of neon Ne2 molecular orbital follows the above principle and Hern's rule of maximum multiplicity. The 2 electrons are entered into the sigma 2s of bonding molecular orbital next to the sigma star 2s antibonding molecular orbital. 2 electrons occupy sigma 2px, 4 electrons go to the pi 2py, pi 2pz bonding molecular orbitals, and 6 electrons go to the pi star 2py, pi star 2pz, and sigma star 2px antibonding molecular orbitals. Let us consider molecular orbital energy level diagram for the Ne2 molecule. This is an energy axis. These are the 2s and 2p orbitals of first Ne atom. This is the 2s and 2p orbital of second Ne atom. The combination of 2s of one Ne and second Ne atom forms two molecular orbitals. One is antibonding sigma star 2s and bonding 2s sigma 2s orbital. Similarly, we have sigma 2px and sigma star 2px. Then we have pi 2py, pi 2pz, pi star 2pz, and pi star 2py as a antibonding molecular orbitals. So these are the atoms of Ne. The 2s orbital of Ne contains 2 electrons. 2p orbital contains 6 electrons in both of Ne atoms. The molecular orbital sigma 2s occupies 2 electrons, sigma star occupies 2 electrons, sigma 2px occupies 2 electrons, pi 2py occupies 2 electrons, pi 2pz also occupies 2 electrons, pi star 2py also occupies 2 electrons, pi 2pz also occupies 2 electrons, and sigma star 2px also occupies the 2 electrons. So in total we have we have 8 electrons in the anti-bonding molecular orbitals and 8 electrons in the bonding molecular orbitals. Let us calculate the bond energy and bond order for the Ne2 molecule. Before that, the molecular orbital electronic configuration for Ne2 molecule is written as Kk sigma 2s2 sigma star 2s2 sigma 2px2 pi 2py2 pi 2pz2 pi star 2py2 pi star 2pz2 sigma star 2px2. The bond energy can be calculated as minus 8 into minus b plus 8 into plus b, that is equal to 0. Bond order can be calculated as number of electrons in BMO minus number of electrons in ABMO, that is equal to 1 half 8 minus 8, that is equal to 0. In this molecule, all the orbitals are filled with the electrons, so bond order is 0. The stabilization energy is also 0. Therefore, Ne2 molecule is not stable and therefore it does not exist.